Hi, this is O'Connor. I've been asked to talk on a panel for China Daily tomorrow about the future of AI in manufacturing industries. And I briefly want to cover the following, and that is forces at work, very briefly. AI in manufacturing, just want to quickly go over what is the context that we are talking about. Then I'm going to talk about factory examples of actual factories I've visited and consulted with, advising on continuous improvement. And then we're going to finish up with some action steps that the audience can take away, because if the audience cannot take away anything, then what's the point of listening to me in the first place? So, what is innovation, or what's happening about China 2025, which is basically the Chinese version of Industry 4.0, and more recently their announcement about wanting to lead the field in terms of development and pushing AI in manufacturing, especially with the large organizations in China. Well, basically, this is all about a top-down approach that governments will take in nations in terms of kick-starting innovations. And as you can see in the orange fields in the innovation framework I've got here, notice that the government Belt and Road Initiative, China 2025, and now this AI in manufacturing are government plans to actually push the field forward, whether it's in logistics or physical infrastructure or IT. On the other hand, there are other aspects of innovation that are much more sustainable in the long term, and that is when we have a lot of R&D or science-based innovation that goes on in the West, and that heavily depends on the owner mindset, which is not always fast focused on R&D, especially in developing countries. Also, innovation depends on collaboration, and collaboration with large multinationals, brand names from developed nations. For example, GA, S. Oliver, Puma, IKEA, large brand MNCs, they're increasingly collaborating with factories in China, suppliers in China and in other countries. And through that, the suppliers are able to innovate and move to higher levels in the value chain. Finally, you have the influx or the liquidity and funding that's provided by VCs, private investors or startups, which is the purple area here. And that's a big drive now in the world today in various industries, especially in IT, electrical vehicles, EV technology, also in the fintech area, health tech area, reg tech area. There's a lot of different areas with technology attached to them that are attracting a lot of funds from VCs. Wow. So that's our innovation framework, and what we're looking at today is really that orange area. That's what's kick-started this discussion of how China can actually move the needle forward in terms of adopting AI throughout its manufacturing economy, and for that Asian manufacturing in general. Wow. So this is the China 2025 plan. I want to know that, this is a graph that I designed over 3 or 4 years ago, and even IT was on a large front and center of China 2025 plan, hoping that by 2025 that China would be exporting 40% of IT technology. It was the biggest push out of the 10 areas of the China 2025 plan. It had the greatest potential. It still has the greatest potential. What we're talking about today is about the future of AI. Well, what is the future of AI, both for large, for small, for SMEs, manufacturers in China, in the Asian region? So, what is AI? It's an advancement on basic learning, which is called supervised learning and unsupervised learning. AI is sort of the collection of reinforcement learning, but also deep learning, where you're actually using algorithms in the computer to actually learn by themselves rather than the rules that operators give to the computer. And it's kind of like throwing thousands tens of thousands, hundreds of thousands of pictures at a computer and ask them to discern between dog, cat, dog, cat, dog, cat. And then they learn over time to actually recognize a dog or cat based on learning from thousands and thousands of pictures. And that can be applied in many different operations in the world today. Okay, what's going on in manufacturing absent AI or even in the presence of AI? Well, the big thing that is driving part of the Industry 4.0 is the automation pyramid, and that's where we actually think about manufacturing as a various control layers, starting with ERP at the top, enterprise resource planning. Then you've got the manufacturing execution system. Then we've got SCADA, supervised control and data collection system. Then we've got sensing manipulation of PLC and production process, sensors, actuators, motors, hardware, instrumentation. Basically, production process is actually what you see in the factory. And so you've got all these controls going over the top of what's happening in the factory. But the key point of this automation pyramid is to actually generate streamlined collections of data and data traffic between these levels, so you can actually capitalize on and actually use AI because you're capturing so much data centrally through these different layers rather than capturing data in different silos, which happens in a lot of factories today. And when you can capture so much data centrally through these different layers, then you've got this notion of big data. And then what does big data enable AI to do? Well, enables you to throw the data at the AI algorithm and let the AI algorithm do the dog, cat, dog, cat, dog, cat, and then figure out instances where certain control processes are predicted to fail and where they're predicted to succeed based on data that's coming through that system in real time, daily, so to speak. When we're thinking about the manufacturing setting, we must think about how AI is trying to capture or help control process both at a system level, the machine process level, or at the material processing control level. It's not that we have to have solutions at all three levels, but any one AI application can apply at one of these levels. It doesn't have to apply it at all levels to be successful in any organization. So remember, we're looking for context here. We're looking for context, system, the machine process level, or the material process level. These are areas where we are collecting data in the manufacturing processes. So other examples of deployment, successful deployment of AI out there? Yes, there are. And what I want to show you here is not to go through these individually, but I want to show you that the areas in where AI has been successfully deployed are in real-time detection, classification of defects, predictive analytics, and also in design. And the other thing I want to show you here is that most of the examples or the successful examples that are coming out of the deployment of AI are in the automotive industry. And why is that? Because automotive industry is kind of the forefront of automation. It's the forefront of the adoption of Industry 4.0 technology, or that pyramid I showed you 2 slides earlier. And so naturally, with that data collection, we could start to deploy AI algorithms, machine learning and neural networks to that data to actually benefit the automotive manufacturing process. Wow. So would it work for a low volume SME? Maybe not, but I just want to show you where it is working today. Wow. Okay, and here's some other examples of deep learning, which is probably gone beyond the factory, and that is for fault diagnostics of bearings. Now, every machine in a factory generally has bearings. If something is spinning, there are bearings that enable that close to frictionless spin. All right, you want to have minimum friction so you can actually keep that spinning with minimum variability and control over time. The deep learning approach has been used to detect hotspots on the surface of PV photovoltaic panels, and for fault identification in insulators, inspection of power lines, and also in electric vehicle applications. So already AI is being deployed in various industries, automotive being a dominant one. Okay, so what does the Kearney report and Deloitte recent surveys of companies around the world say about where they're deploying AI, or where companies are having success in AI? I just want to point to you on the manufacturing side that definitely it's been deployed, or they view that AI is likely to have high impact, more likely to have high impact when in the area of predictive maintenance, in the yield, throughput and line optimization, and in product feature optimization and AI-assisted product development and predictive defect detection. So you're talking about quality control, you're talking about predictive maintenance, and you're talking about design. Remember, we're not here talking about how Amazon is predicting your purchases when you are shopping. All right, we're not talking about consumer behavior here. We already know AI is being used there, but today's talk is about AI in manufacturing. What does Deloitte have to say? Well, same thing. Their survey has shown that the adoption of smart production among the companies surveyed is likely to happen in factory automation, quality monitoring and defect management. There's that quality and defect management deployment of AI. Example again. Wow. So, there's obvious pockets in manufacturing where AI can be beneficial, and it's likely in these areas where companies are able to collect a lot of data, more sensory technology, etc. So let's bring it back to AI in Asian manufacturing. What does that mean for Asian manufacturers? Well, I just want to bring things back to home here. I grew up on a farm, which is basically a factory in itself. And really, a good factory starts with documented processes, then continuous improvement, and then digitalization. Digitalization is the advent of Industry 4.0, but documented processes and continuous improvement, that's been around for the last 20, 30 more years. And this is a stage where a lot of SMEs, manufacturers in Asia are still at. They haven't even reached the digitalization stage. I wanted to point out here that even to move to the digitalization stage requires a stronger strategic vision of the owner, an owner mindset, and a focus on skill enhancement of people in the organization. Because once you go to digitalization, you are decentralizing many more of the control operations in the organization, allowing people on the factory line to stop a machine, to stop a process the minute they detect a problem. Now, I know in leading factories around the world that is happening already. We know that happens already. But for the mom and pop operation, for the SME in Asia, that doesn't necessarily happen. Once a production line starts, normally the operators on that line do not have maybe the wherewithal or the data, or they do not have the power to actually start and stop the production line. So, it requires a bold owner to actually give that control to people on the assembly line. These are people issues. These are talent management issues. So you've got a strategic vision, you've got the talent management issues, but also there's a problem in Asia where an owner sees an opportunity to invest $1 million in digitalization or new machines to support digitalization, or buy $1 million property. They're likely to go for the latter because this is something that's a bird in the hand rather than two birds in the bush. And so we understand that mindset. That is a norm in a lot of factories in emerging economies, especially in this region. So we want to go beyond that to get to that digitalization stage. Okay. So let me just show you some examples of companies. What I've got here is two headphone manufacturers. On the bottom, just behind me here, was a basic headphone manufacturer, but the one at the top is a much more advanced, and you can see the difference where the basic one has a really generic assembly line, very labor intensive. The one at the top, yes, there is still labor intensive, but it's much more systemized and controlled, supervised and clean, and they've got much more control over the outcome of the assembly line. That's very important for a starting point, and that's come through continuous improvement. What about here? At the bottom, we have a workshop making a hoverboard. At the top, we have another assembly line where they're actually fully automated with manual assembly, of course. The manufacturer of hoverboards, again, of course, the one at the top can produce 4 times, 5 times more hoverboards every day compared to the one at the bottom. If the one at the bottom, the machine operator, assembly operator, gets sick, then they cannot make hoverboards for the whole day. Whereas an operator gets sick at the top, you can replace them very easily because there's much more flexibility in labor rotation. So you've got to have talent management and processes in place before you can even go to a digitalization model. And then suddenly you can have processes in place at the receiving inspection stage, and that's where you can start to collect data. As I said earlier, at the material collection stage is a good place for factories to start to collect data, because normally poor materials leads to defects in the assembly line and leads to a lot of sustainability problems or quality control problems at the other end of the assembly. And so the one at the top has a machine actually testing every cell that is delivered to the factory, whereas the one at the bottom, they're not doing that. So this is a leap that the SME at the bottom needs to make to the one at the top. And the one at the top is much more closer to digitalization than the one at the bottom. Again, even when you are manufacturing something like a car audio like here, and then you've got the manual collection of data for quality control as we show here, but it seems to be collected. It's not digitally collected, and they probably want to go to another level where they digitalize it. Then they can start to piece together with data to find out how they can improve different processes. In this case, I actually show the owner the processes that may need to be re-engineered in order to minimize control problems in the assembly line. And that's with the screwing in of the front panel and the soldering of the IC unit on the back panel. Wow. And then near the end, I just want to show you, even in the burn management of quality, keeping components apart is very important. Again, another operational detail that factories moving to a digitalization stage need to think about even before they start to digitalize. Wow. And then we can talk about the burn-in room, which is an obvious area for electronics factories to digitalize, because this is kind of like the final QC check on the battery that's going into the operation of the device that's been manufactured. So what I'm showing you here is that a lot of examples where factories are not there yet. They're at the documentation continuous improvement stage and not even at the digitalization stage. If they were to go to the digitalization stage, I'm saying that you want to start to digitalize the materials received in QC. The rework area, the quality control area, and the burn-in room area, and start to capture more data in that area. And then hopefully over time you can start to use AI when you actually fully digitalize the operations, when you go to a larger scale. So what can we learn going forward? What takeaways can I give the factories in China, in the Asian region, the general SMEs or the medium level size factories, which actually is the predominant number of factories in the Asian region? Number one, transparency is a big thing. Now, we've got border closures, but transparency was always very, very important. Clients, international clients, put a great deal of emphasis on transparency. If it's for their compliance, it's for their quality, it's for managing their brand reputation risk. And so fully digitalization system can help in transparency, border closure, no border closure. And Pivot 88 is a third party that actually helps factories by actually inserting a tablet into the production line area, enables the digitalization of various line operations and actually train operators in the factory. And of course, they work on behalf of clients and they charge the factories for this a minimal amount, but it's a way of a factory, if they adopt this technology without changing the machines, they can still be fully labor intensive, but at least having a tablet technology to start to collect data digitally is one way that a factory can move towards digitalization. Another way is thinking about factory audits. Many clients do not have a factory audit undertaken. I've got 500 factory audits here, and I've been analysing data. Notice the variability. Some factories have a twice as high level of quality, maintenance, environment, and general scoring on factory audit than other factories in China. This is 500 factory audits, mind you. Why does that matter? Well, just because clients do not order a factory audit, it doesn't mean you as a manufacturer should not order a factory audit to come in and to learn how you can make improvements inside your factory, different assembly lines, different processes, different documentation that you may be missing. And this is all learning, and it only costs less than $400, 400 US dollars to bring an auditor in for one day to come and do an audit of the factory. And you can do it without the pressure of a client, without the pressure of an order from a client or of a client that normally orders a factory audit. What else is important about factory audit is I'm finding linking factory audits to product audits. Yes, if you have a good factory audit score, it's likely you're going to have a better product audit outcome. And I've been using big data, machine learning algorithms to find out, is the factory audit linked to a product audit outcome? And I find that the factory audit grade that a factory gets results in a stronger likelihood that they will have a pass in the product audit outcome. And that's another reason why you should put more emphasis on the factory audit, learning from the factory audit and making sure that you can try and pass a factory audit, whether a client orders a factory audit to be undertaken or not. So these are things that companies around Asia can already do, whether the client pays for it or not. That is, getting someone like a third-party digitalization tablet into the factory line, getting a factory auditor to come into the factory line, and also always saying yes and embracing the learning opportunity that product auditors can bring to you. So in summary, there are obvious benefits of Industry 4.0 and AI, very industry specific, large, high volume automated systems. There are obvious opportunities of being grabbed by the industry players. Predictive maintenance, defect detection, field output, yield output, line optimization, quality, all right, throughput, costs, flexibility, industry and parts optimization. These are obvious opportunities being grabbed at the moment for those industry players that have invested hugely in digitalizing their processes. For Asian manufacturers, I would say there's a greater emphasis on them to focus on the continuous improvement and to move towards a digitalization. They're not there yet, especially for SMEs. There are other challenges like talent and security, of course. Future steps, where can you start? Start by measuring more. Learn from third parties like Pivot 88, from factory audits, and learn from OEMs in developed nations. As OEM become your client, they will require of you various quality gates in your operations if you don't have them already. And you can learn from that and actually make that part of your operation standard. Thank you for listening to me today. I hope you learned something for taking away about the future of AI in manufacturing in Asia. This is Neil O'Connor for the China Daily webinar, which will be happening tomorrow, and I hope you can join us. Bye for now.